Okay, let me share my screen. Y'all can see that all right, right? Okay. So like I said, we will be going over CI/CD, a bit of basic GitHub commands, setting up repos through a few various methods. We're going to initialize a new repo locally, and then we're going to sync that to an existing repo that we create through the GUI. And then I'll just show you cloning a repo. Then we'll pivot from there into GitHub Actions. We'll use one of these repositories to write a GitHub Actions file. And from there, we'll go over some advanced GitHub revisioning commands like rebasing, which you'll use to squash your commits, which is great for when you are making a lot of changes. Let's say you're working on a very challenging task and you're finding yourself making several different commits as you're troubleshooting your code. That will be a pain in the ass for anybody else to review. So generally, you'll want to squash all of your commits so that a reviewer will only have one single commit to look through. Let's see. Let's scale back a bit. Let's start with CI/CD. I'm sure you all are already familiar with this process. I think Chandra should have been talking about it a lot during the curriculum, being a DevOps-focused curriculum. And basically, continuous integration, delivery, and deployment can all be thought of different, maybe as different steps in like the entire continuous delivery flow. So starting with just integration, you're basically automating the process of integrating new changes into a repository. So things like Circle CI, for example, can work really well with GitHub, and it will initially spin up an environment where it can run a bunch of tests on the changes that you've made. It could do a lot of syntax checking, and it can run, straight from GitHub as you make a PR. That's integration. Delivery would be the additional step of delivering these changes automatically to, let's say, an automation flow like Jenkins, where we're now not only checking the changes that you've made into the repository, but now we're also running a build command. And we are then pushing that new build into wherever it's deployed. And that's essentially the CI/CD flow. When you're making changes to a repository, you're probably going to be practicing semantic versioning. And basically, I'm sure you've seen this already, but you have three numbers. You have a major version, a minor version, and a patch. So how you name a new version will depend on the change that you're implementing. A major version change is typically used when you're making an incompatible API change. So let's say you're not only adding a new feature, but this new feature is not backwards compatible with the way the app or whatever it is currently used. And minor versions are backwards compatible. So if you're implementing a new feature that's not going to break anything, you'll just want to make a minor update. And patch versioning is for just what it says, what it sounds like, patching bugs and errors, things of that nature. It's also backwards compatible. And you could also add additional labels if you need to be even more granular and specific when you are versioning. And we will go over tagging in GitHub later on. Let's talk about some scenarios though. Let's say you are on version 8 of Next.js, and up until now, Next.js has used a page router API for routing the pages that a programmer will create in their Next.js application. So unfortunately, there's some limitations to this. So let's say the solution that you and your team are implementing is creating an additional routing solution called App Router API. It doesn't entirely replace the page router, but the user will have to choose between one or the other when setting a project. Should this next version be a major, minor, or patch upgrade?
It should be minor, I think, because it's somewhat backwards compatible.
Yes, somewhat backwards compatible, but it could also potentially break, depending on the complexity of the application, of course, right? It could potentially cause a lot of breaking changes, just depending on how these new features are implemented. This is a real world scenario, and what the Next.js team did choose to do was they did choose to release the App Router API in a new version, a new major version, and that was released with Next.js version 9. Let's say you are the creator of an API authentication Ruby gem that utilizes SHA, Secure Hash Algorithm 1 encryption. But in response to concerns about SHA-1 vulnerabilities, you decide to implement SHA-256 encryption, allowing users to select between SHA-1 and SHA-256 by passing in a string when calling your gem's methods. Now, is this a major, minor, or patch?
It will be a patch because it's just, well, it's essentially debugging and it's backwards compatible.
Yes, that sounds like I see your logic there, but in the real world situation, the creators of the API authentication Ruby gem released it as a minor change. My thinking is they did this because they are implementing something new as opposed to just simply fixing something. Because it's not necessarily a bug, right? Or an issue that was caused by SHA-1. They just wanted to be proactive about giving users an additional option for additional security.
It makes sense.
Now, let's say, in addition to allowing users the functionality to choose between SHA-1 and SHA-256, you also decide to change the default encryption algorithms from SHA-1 to SHA-256. Now, should this be major, minor, or patch?
At the risk of being wrong twice, I would probably put it as minor, unless you want to count it as not backwards compatible, then I guess it'd be major.
Yes, it's definitely not backwards compatible, because if it's changing the default behavior, existing applications using this gem might expect to be using a SHA-1 encryption method, and they would now need to update their code to specify SHA-1. This is actually an issue that my team has faced because we use Ruby for some of our applications, and we've had to basically force our shadow application to use an older version of this API gem because we haven't implemented any of the changes to work with the newest version yet. So that is semantic versioning, and that's what you're going to want to essentially follow based on really how your organization implements it. So wherever you land, when you land a job, they're probably going to have their own sets of standards and rules and guidelines for what counts as a major, minor, or patch version change, because as we've seen just now, it can be a little subjective in addition to being objective. Like, it can be interpreted in multiple ways. So it's not so black and white. I think, Matt, you made some good arguments for which version change you would have chosen, but in the real world scenario, they went another route. So basically, you'll just want to communicate with your team, and once you're in the flow of working with whoever you're working with, it'll all come a lot more naturally. Next, we'll be going over GitHub Actions, and basically GitHub Actions will automate your workflow. It allows you to implement building, testing, and deploying deployment through pipelines. And it could be triggered either through pull requests or by merging a PR. GitHub Actions is free to use, and it utilizes YAML configuration. If you haven't been, I think you have already worked with YAML quite a bit when it came to things like Ansible, and I don't think Terraform is YAML. I think, yeah, Ansible should use some YAML. Chef uses YAML. A few other things that you've touched might have used YAML, but basically it is a human readable data serialization language, and it stands for yet another markup language. Comments can be identified with a pound or a hash, but comments are only single line. You can't, YAML does not support multi-line commenting. So each line that you want commented will need to be suffixed with the pound character. YAML has features of Perl, C, XML, HTML, and is a JSON superset, which means that JSON files are valid in YAML. You can write in the JSON syntax when configuring your YAML files. YAML is a declarative language, which, unlike imperative languages, you're essentially defining the result that you want your application to yield. And it leads to faster dev cycles and less code. It's adaptive and requires a little less maintenance. All right, with all that said, let's switch over to our Visual Studio so we could run through some of these Git exercises. I think I want to start with, what was this? This was something that I think I started showing you guys a few Saturdays ago, but I didn't get to finish it in time. It was Terraform. It was running Ansible through Terraform. So I did show you the first part where I basically had a Docker container set up, and this Docker file is really simple. It just essentially creates a Terraform working directory. It copies from this source repo to that Docker container, and it essentially allows me to run Terraform files without actually having Terraform installed on my local machine. So let's go back to that window. J is a really cool Zeesh and Bash compatible library. It's called AutoJump. It allows you to jump to any recently visited folder as opposed to trying to memorize what your working directory URL is. Let's see, what else? What was I going to do? I was going to show you tfdocker. Right. So tfdocker, the way this works is you run a docker run command. This --rm says to remove this container once it's done spinning up and doing its thing. So as soon as this code is run, this container disappears. Let's take a look at AWS. Actually, I need to change my sharing. Let's share the entire window. Is that what that is? I can't tell if it's doing the entire, okay, desktop one. All right, so now you see in AWS, I've got nothing running. Let's go back to Visual Code. Make sure that's sharing. If I were to run my Docker run Terraform Docker init, it's now initializing. And let's take a look at what this Terraform file looks like. Okay, so it's initialized. I can now run my Terraform Docker plan. So let's run that plan. And if we look inside my Terraform file, I'm provisioning, well, I'm calling the AWS provider. I'm setting my region. I'm setting the requirement for that in Terraform module, and then I'm defining my AWS instances. So these are going to be generated by Terraform once I run my Terraform apply. Because this is running inside Docker, I can't interact with it once it starts running. So if I were to just run apply right now, it will fail to run. It will try to run, but it won't complete because it will be expecting an interaction that it can't provide, because the container will spin down as soon as it asks for that command. So I'm getting this end of file error. So I could pass in an argument, auto approve, to essentially provide that yes line, that yes response, in lieu of me having to pass it in manually. So now we're running our Terraform apply. Once this is up and running, let's actually take a look at what's happening. Because we'll see that, yes, it's generating these modules, these Terraform modules, but as it runs, we're going to see some Ansible code being run as well. If we were to look at what that looks like here in the Terraform file, we're doing some additional necessary setup, like setting up our security groups. And then we have basically the portion of the Terraform script that runs Ansible. Here, we're doing a few preliminary steps about passing in a required IP that's generated, so that gets sent to this file. We're not actually using this. I was going to use this for the last part of the flow, which I didn't finish implementing. I was going to have it essentially host or show the output inside a browser. But here we could see that Ansible is running and it's doing its thing. It's running the playbook, the Ansible playbook. And if we look inside our Ansible config, we have that IP that it was requiring. We have some necessary, I guess, it needs to know the user sign and name. It needs the key to be able to SSH into the instance and run the Ansible playbook. So with all that, we can now go back into our AWS instance, do a refresh, and we can see that we have our EC2 instances. So that was the Terraform Ansible demo that I started setting up a few weeks ago. Again, it's pretty straightforward. You set up an Ansible config, you set up your Ansible playbook, which, let's see, I believe it's just this. We called it instance. It's, as you can recall, really just a YAML file, a list of parameters, really, pretty much following a key value pair syntax. And what it's doing is, as these names suggest, it's installing packages, it is formatting a storage, it's making a folder, it's mounting that storage. And then the part that I didn't quite finish was cloning a repo, mounting it, and then hosting the front end. I think I was trying to do it through PHP, but I didn't finish. And then essentially opening that up in a browser. But I didn't get that part. What's important is that we see a playbook and that we see it was run by the Terraform file. So now that we have this, what I want to do is I want to share it with you all. And I'm going to do that. First, let's destroy this instance so it's not just running in the background, because we no longer need it. I'm going to pass and destroy. We're going to pass and auto approve. And now this will go away in a sec. what I want to do now is I'm going to create a new repository. I'm going to call this TF Docker. I am going to add a README file. I'll say Docker container for Terraform that sets up AWS EC2 instances and runs the enhanced playbook. Let's create the repo. Instead of cloning it like you normally would, I want to show you how you would map an existing repo on GitHub to a repo that you initialize locally. So let's say I'm going up here, I'm going back to my TF Docker folder. Let's run a git status. We see that nothing happens because this is not a Git directory. But let's say I wanted to make this a Git directory because I've already got all my files here. I will do a git init. This allows me to initialize this folder as a Git repository. Now, if I do things like git status, I can see that I've got all these files that I have not committed. Before I commit them, I want to connect. I'm actually thinking whether I should commit them first, but I'll go the first route of connecting this to the external repo by saying git remote add, let's call it our origin. Git remote add origin, and then we take in the URL of the repository. Now, if I run a git remote -v, V is for verbose, it will tell me what my remote connections are with a URL to that connection. And now, if I do another git status, I could see that I don't have these added. I could either add these files one by one. I could add them through a star, but generally, you'll only want to do that once you've made a git ignore. So let's create a git ignore file. I don't have anything in here. I'm just going to save it. I'm going to close it. And now I'm going to git add all these files. And we can see that they've all been added. Except for, I forget exactly where, or I think actually any file that is preceded with a dot will not automatically be added when you do a git add wildcard. I think you have to specify the dot first if you wanted to do that. I want to add my git ignore, so let's do that. I don't think I want to add my credentials because that's my environment file. So I'll add my Terraform directory. Whoops. I don't need my Terraform log, I don't think. And we will then commit all these changes. We'll add a message, so -m for message. Let's call it init. And let's try to push our changes. Oh, I forgot to, I wanted to switch branches, but I forgot to switch branches, but it's okay. I'm going to push to main. I want to, let's see, what's my remote called? Git remote V. My remote is called origin. So I'm going to git push origin. Main is the name of my branch. And I am now running into some conflicts. So because this has an entirely different history from the repo I have here, Git is now complaining. So let's try a few things. Let's first try fetching from our main repository. What's happening now is I'm pulling all the branch and commit history data locally. Now I can also do a git pull main, but it doesn't like that either. There are conflicts, or actually that's saying I have correct access rights. That's strange.
Yeah, usually if you just get pull rebase, it'll fix this.
Okay. I'm trying to think, why would I not have access rights to this? I wonder if it's, I made this repo. I just made this repo myself. It's, oh, but I made it under the DevOps organization. Oof, what is my password? I remember my own password. Nice. Okay. So I should have access. I don't know why the hell I don't. Oh, snap. I think I got an email recently telling me that my token was going to expire, so I would need to set up a token again. Let's not worry about that right now. Should I try now? We were getting the conflict. I couldn't get pull. It's telling me I don't have access, or actually it's telling me I don't have the related histories. What I can do in this situation, because there are separate histories, is I kind of always forget the command for this. Where is it? Allow unrelated histories. So let's pass that in. It wants me to enter a commit message. And if I have an empty message, then it's going to abort. So let's just say, I don't know, hello world. Let's write quit. Now we've merged changes. Where are we at now? Let's add our README. If I don't want to add and commit, and I want to just do it in one command, I could do a commit and pass in A for add along with message, and it will add the README. So let's say add README. So we get status. We could see that the README was added. And now let's try pushing to, it might not let me because of my, what is it called? Access. Well, that's interesting. It's actually letting me. Right, let's take a look at what's happening here. Nothing yet. It's going real slow. This repo is surprisingly bigger than I realized. Oof. Okay, so it was rejected. Large files detected. So what the hell?
Oh, your whole Terraform directory is on there.
Good call, good call, good call. Let's remove that. Let's totally not do that. Okay, we are going to remove the .terraform. Oof. Let's try. Oh, it's because right. Okay, we've now removed Terraform folder. I think we should be good. Let's commit this. Okay. Now let's push. Right, we were doing this to main. Wonder if there's anything else I should have removed. What did I add earlier? I added. Oh, the rest of the window is gone. That's strange. There shouldn't be. Oh,
I know if you've already so you create your git ignore, right? And if you've already got files that are saved and you add it to your git ignore, it
mhm.
won't remove them. You have to remove them from the repository, I believe. It's a big pain in the butt. I just know I've done it several times.
Okay. So when I did the git rem rm -r for recursive, that wasn't enough to remove it from the repository because I thought that would have been.
Is it because they're already staged?
It's something to do with that, yeah. But that you're right, that should have removed it. But let me do some more research. But I've had this issue so many times. It's
Yeah, you
annoying.
deleted the files, but I think if it's staged,
Oh.
it's separately because it's in
Yeah.
Git.
Right. So, okay, how do I remove it from staging? Because I can't remember right now. Let me see.
Just throw a Git stash out there and start over. That's how I do it.
I could do that. So let's see if we can figure out how to do it without doing that. Let's see.
I was going to bring this up when Chandra was going over the git ignore, saying you want to make sure you add things to your git ignore before you add those files to the staging area, or you got to go through this process here.
If
Yeah.
you just git status, it should remove it from there's a command to remove it from the staging.
If I get status, then what?
It'll tell you how to, if you git restore, or
Uh,
did you recommit it?
I did already commit it after I did the remove.
Oh, I guess you just have to do a reset.
Okay, I could try reset. I might have to because I've already committed it. Let's see.
You'd have to reset one commit back.
One more. How do I specify the number of commits I want to reset?
I would have to look it up. I forget every time.
Okay. I haven't done this in a long time, but you could also get reset to a specific commit. What I typed here, adog, it's an alias that I created. Kind of forget what's in that alias, so maybe let's take a look. Okay, so it's basically it's git log all, and then you're adding a few flags like decorate, one line, and graph. So if we were to type that out manually, git all, we're showing the entire log. We're decorating it to give us a nice little visual of what the commit history looks like. We'll do one line, and then we'll do graph, and this is the result. We can see that we're currently in commit F54827. I tried resetting to try to go back to add readme. What I really want to do is maybe go all the way back here before I merged. So let's do a git reset. I think you could just pass this in. Cool. I should be back at this commit. if we look at our status, nothing has been added. So let's do an add all. That should add all of my files. I'm not going to make the mistake of adding the .terraform. Looks like it's gone anyway. So add git ignore. Now let's commit. Just make a new commit, call it init. And let's push to our main. Ta-da. Cool. Any questions about some of the stuff I just showed you? Okay, so we now have this. Can't be forked, but it should all be visible and accessible now. I'll share this in the Slack later on. Ooh, I really shouldn't have this up here. All right, let's see. I want to remove my PDM file. Let's.
You're probably getting an email right now from Git Guardian.
Wow. Let's see. So what I can do is, if I don't want to revert to a previous commit, we want to see if we could unstage this, right? So let's try saying git. How the hell do you unstage?
What was that command that shows the all the branches?
Sure. It is git log with a few of these flags. Let me type that into Slack right now.
Okay, yeah, because whenever I use log, it just shows like the commit messages usually instead of like the branches in the commit code like you had. That was nice.
Yeah, it's really cool to be able to see it with all these pretty little colors. But yeah,
Status.
what was that?
Is it git status that shows the branches?
No, it's git log.
Oh, okay.
I just pasted it in Slack with a few of the flags that I passed in to get that graph.
Okay, great. Thank you.
I'll delete that quote later. So we are now trying to unstage a specific file. Let's say let's try doing a restore. We'll try restore, and the file name was DevOps EW. I hit tab to autocomplete. Git status. I don't know if that worked. Let's try a git reset. DevOps. I might have to, maybe I have to remove a cache of it. Let's see. Yes, I did mean cache with 2 dashes. All right, now that worked. Okay, cool. So yes, I had to do both the restore to remove from staging, and then I also had to remove the cached version of it because I have already pushed. So now that it's been removed, let's do another commit. Remove PEM, push origin. Let's say let's look at this. This is why I want to work off of a fork and a branch. Wanted to be able to show you how to squash commits. I could see we have 3 commits here, but I'm not working off of not making a pull request and not working off of a separate branch. I'm not sure if, let me do this. Nope, it isn't like that. I can at least squash these two commits. So what I did was I called rebase with -I flag for interactive, and this is the interactive session. I am using Vim to edit my file. I am replacing pick with squash. I could also just type S for squash. Whenever this file opens, it shows you the commands that you can run. So squash my commit means use the commit, but meld it into the previous commit. So now I am potentially helping a code reviewer by limiting the number of commits that he has to read through. The following untracked working tree files would be overwritten by checkout. That's exactly what I want. I don't want that file in there. Please move or remove them before you switch branches. I guess it wants me to remove it. Always just copy this again later. Hey, let's try squashing again. Although I'm not 100% sure. Let's try status. X again. Cool. So that worked. Didn't like that the file was there. It's now opening the second interactive message. And this basically just shows you what the commit messages are going to be. I'm totally fine with this. I almost never change the second file. So I'm just going to quit. And we have successfully rebased. If we refresh. Oh, one last step. I have to push. So let's push my changes back to main. -F is to force the push. Because I'm tired of it giving me any sass. And if we refresh, we have squashed one of my commits. Not this one, but this one. And that is rebasing. I would still like to show rebasing from forked repo. So let's go back up a folder. Let's actually grab something else. Yes, git pair. Let's go to git pair. Let's now status. Right. My alias GW is basically a combination of a few different commands. It is git remote -v, which grabs your upstream branches, or sorry, your remote connections and URLs, and the command for grabbing branches, which escapes me at the moment because I always use my alias. But let's see. What I wanted to do here was make some changes to the code so we could see squashing and how that affects a pull request. So if we take a look at what is up there now, I think we already made one example. Let's go over to wherever this repo is. I'm going to copy paste this URL. Oops, what is going on? If we look inside the original repository, we will see that I have a pull request open. It's only got one commit. So let's try adding some additional changes. I'm still in my squash example branch. I am now going to collapse that folder. I'm going to open up this git pair folder, and I'm going to make some changes to this file. Let's try deleting this. I'm gonna save. And let's also, let's commit first. So we're gonna commit, gonna add all the changes automatically. Some commits, or let's just call it move goodbye. Then I'm gonna push the origin. That's the name of my remote. I'm gonna type out my branch, hit tab to autocomplete, and we have a push. Let's make one more change. And now let's add goodbye world, but preceding hello world. Let's do another commit with A to add the file automatically. And we're gonna call it re-add goodbye, push origin, squash tab autocomplete. Now, if we look at my PR, I have multiple commits again, which is no bueno for whoever's reviewing my PR. So let's do a git rebase -I for interactive head. How do I explain head? Head is basically, it's kind of like the tip of the spear, right? It's where you are in your git log. So if we were to do our git log command again, we see all these different commits. Head is basically the commit that you're at right now. So when we're doing a rebase and we're calling the rebase command with I for interactive, and we're specifying the head, we can specify how many commits we want to go back. So let's say I have my 3 commits here. I only want to go back 3 commits. So I'm going to do a head tilde 3. And now I could see the 3 commits that I've added. And again, it's interactive, so it tells me all the stuff I need to know. What I want to do is squash my commits. Hell, if I even have a bad commit that I want to get rid of, I could use D or drop. And we see here that basically removes the commit. So let's do that. Let's quit. Again, the second window will always open. It asks you to confirm the commit messages that you've added. And it says an empty message aborts the commit, but it's not empty because it's already got commit messages that we've added. So we could safely quit. And we have successfully rebased. Now let's do a git push origin. Let's force it. And the name of our branch. And let's do a refresh. Now we've got one commit. We don't have goodbye world because, as you remember, I chose to drop that commit as opposed to squashing it. Any questions? Cool. There is one last thing that we are gonna walk through, and that is creating a GitHub Actions file. If we go to, where are we? Where did I make that file? Okay, I think it's this. Before I do that, let me share an example of a GitHub Actions file. Have you guys worked with GitHub Actions yet?
No.
Okay. GitHub Actions is really cool. It's basically a free continuous integration, continuous deployment pipeline built into GitHub. And it's essentially just another tab that you can access when accessing one of your repos. And it's a YAML configuration. You write out some details like the name of your configuration and what happens as a result. So it's kind of like an Ansible playbook. You have here, what's happening is if, or not, let's say on a push, whenever anything is pushed to the main branch, then we're going to call this workflow dispatch. What happens then is we create a job. That job will run a build. It runs on the latest version of Ubuntu, and it uses these steps to call a checkout action. I believe this is an API call. It will then set up a Docker build action. It logs into the registry. I think this is all Azure, by the way. Azure is a pain in the ass. And it builds and pushes the container to a Docker registry, actually, I think. And once all of this is done, it then deploys it to a production environment. And I think these additional steps, the name, the ID, this is just what's going to appear in the log. So that's a more complicated GitHub Actions file. We're just going to work with a simpler one. And that is going to look something like this for now. We have this repo. Let's see if maybe it was this one. If I were to make a change.
So those GitHub Actions, are you limited to whatever like is available on that API? Or are you able to do anything you want? Like if you were running your own local tests with Jest or something, are you doing that? Or is it specific to GitHub stuff?
No, I
Like-
think that's you have flexibility. It's not specific. When you say specific to GitHub stuff, what do you mean?
Like I'm not sure what I know, like, you know, GitHub has a million features, right? So is it made just to use like the tools on GitHub and whatever the API has access to that they built for with their workflows and stuff? I haven't messed with it, so I'm not sure if are you automating like pretty much anything you want local to your project, because you can kind of do that in the build, I guess. I don't know. I'm just trying to figure out like what the features are.
Right. Yes, you could do it locally, but basically, I guess anything you could do locally, you could do through GitHub Actions as well. And the API that was in that one example that I had closed, I believe that was that's actually an Azure API, or it might be a Docker API. So yeah, these APIs are provided by outside of GitHub. So depending on what kind of flow you need, you'll just read the documentation from either Docker or Azure or Google or AWS, wherever you really want to deploy to. And you could call their APIs through here.
Okay, yeah, because I've seen, you know, you push to some repos and it'll run a test on GitHub before it's allowed to be even pulled in as a PR. So is that using your local test files and it's just like displaying on there, or is it running a test through GitHub?
It's
through
GitHub.
It's set up. So let's say you have it set up to like set up a Docker container first, right? It can run the test inside that Docker container.
Okay, so it's executing something locally, but it's being executed through GitHub, like being triggered through GitHub.
Yes, it's triggered through GitHub. Where is it running?
It's running on GitHub.
Okay.
It's GitHub servers. Yeah, I looked all this up. I sent a link, and that'll basically take you through the process of setting up a GitHub action on your GitHub profile. I sent it in the main Slack channel. It has you set up actions. It's actually really easy compared to the stuff that we've done, and it's very cool. It's basically just a resting API. You get about 3,000 minutes. So instead of having your like a Flask app running 24/7, you get like 3,000 minutes of GitHub actions, and it spins up instances and runs servers and does all kinds of cool stuff for you.
Yes, thank you for that, Chad. Yes, definitely. Like with a simpler example, it is running just on GitHub. I want to add, you can do more complicated stuff. Like I think with Azure, for example, you would push a Docker container either to Docker or to an Azure registry, and you can run anything inside that container through commands executed in the workflow. So you could do more advanced things like that, or you could just have everything running on GitHub, like Chad said. And so the simple example here, it's the same one that you'll have in the curriculum README. We basically have a name. We say on push to the branch main or on a pull request to the branch main, this will happen. Let's see. Did I make my PR? I committed, but I did not push. So let's push to, do I have my promote set up correctly? Yep, I am pushing to origin. And I think I'm just on main. Yep, I'm just on main. So git push origin main. Upon pushing, let's go to actions. And we now see that a new workflow has begun. It's in yellow as opposed to being complete. And let's see what's happening live. So on Ubuntu, on GitHub, basically like an Ubuntu session instance on GitHub, code is running. What we specified in our actions config is happening. We basically asked it to echo a few statements. So if we look at our YAML, once it's running, it's going to echo this message. And then it's going to call the current working directory. And the syntax, you could run multiple steps using pipe. And if we look at our complete job, we could see the log at each step, and it's showing the working directory. Any questions?
So when those tests are running in the PRs, it's just running like an npm run test command, and it's not, the tests aren't created in the workflow, right? So it's just like running just whatever you created locally on your app. It's just running those pre-made tests, and there's nothing different.
Right. If you want anything different, you'd have to set it up. So however your app is set up locally, you can have it run through a GitHub Actions, but you would probably still have to call the commands that you'd be calling locally through the configuration file.
Right. Okay.
Cool. Awesome. I think that's about it for what I wanted to demo. If we go back to our repository, your assignment this afternoon is to do a bit of GitHub Actions yourself. I didn't show you Git tagging. I'm sorry. It's in the README. It's really straightforward. Honestly, like there's just a few commands that you'd really want to remember for Git tagging. You could have a Git tag. I'll copy paste these all into the Slack channel as well. So if you pass in an A, that's for annotating a message onto the Git version that you want to set, or the tag that you want to tag, I should say. So like, let's say I wanted to have tag my PR as version 1.0.0. I'll annotate a message. This is the command that I would pass in. If I wanted to search for a tag, I could write git tag to list all the tags, and I could specify that it lists only a particular version using 1.2 star. So I'll paste those in the Slack. I think that was all that I haven't gone over in the Git revisions exercise. Okay, we fork, clone, create a new branch, pull requests, Git tagging, using git ignore, did that. We did some Git reverts and additional Git best practices. I guess they wanted you to do this exercise of explaining for yourself what best practices are in Git. And you can go over that as well. It's in day 2 of the CI/CD folder. And today's other assignment is to create a GitHub Actions workflow that will trigger on every push to the main branch of your repo. and it should do the following. It's got these requirements, and I believe that's it. I think that's your only assignment this afternoon. Any questions? Yeah, that looks like the only assignment. Cool. Well, I will open up some breakout rooms. Nick and I will be in the main room. Slack or ping or Zoom if you have any questions.